Hi everyone, welcome back. I hope you have revised the previous video on vector algebra. If not, you can find the link in the description below. So today, this video is in continuation with the previous video. So here we'll begin with addition of vectors. Vector AB is the displacement from point A to point B. Similarly, vector BC is the displacement from point B to point C. Now if I ask you what will be the net displacement, you will have to take up the initial point A and the final point C. So AC will be the displacement. Therefore, vector AC is equal to vector AB plus vector BC. Now this is known as triangle law of vector addition. Now suppose A is another vector, B is another vector. If we need to add them, we need to position B without changing its magnitude and direction. Now what will be the resultant? AC. Yes. So vector AC will be vector A plus vector B. If I plot vector B backwards, changing the direction, then the resultant will be A minus B. We know that AB plus BC is equal to AC. So AC equals minus CA. Putting this in equation 1, we get AB plus BC is equal to minus CA. AB plus BC plus CA is equal to 0 because the initial and the final or the terminal point is same. Now BC dash is equal to minus BC because BC dash is nothing but BC in the backward direction. So AC dash will be the sum of AB plus BC dash. So AC dash is the difference of A and B. Let's take another case of a parallelogram. How will you take out the resultant? Simply draw parallels. So the resultant will be A plus B. Now this is known as parallelogram law of vector addition. From the figure, we can conclude that vector OA plus vector AC is equal to vector OC. Since AC is equal to OB, we can write the equation as OA plus OB equals OC. Now let's begin with the properties of vector addition. So vector follows commutative property, which means the sum of vector A and B will be same as the sum of vector B and A. Same as we discussed before in parallelogram case. Another property is associative. So A plus B plus C is equal to A plus B plus C. Additive identity. If you add something on a vector, but the result does not change, so that is known as additive identity. Here, A plus null vector is equal to A vector. Let's jump into multiplication of a vector by a scalar. If you multiply 5 to a vector A, it can be written as 5A, and this is also a vector. If I ask you to calculate the magnitude, you can write it as, if A was plotted as, so after multiplying it 5 times, the length of the vector will increase. Now to generalize the equation, we are keeping the scalar as lambda. So lambda A will be equal to modulus of lambda and modulus of A. If lambda equals minus 1, then lambda A is equal to minus A, which is negative of a vector or simply additive inverse. If lambda is equal to 1 by magnitude of A, where A is not equal to 0, which means A is not a null vector. So lambda A will be vector A by modulus of A, which is 1. So it can be written as a unit vector. If lambda A is a unit vector in the direction of A, we can write the unit vector as vector A by mod of vector A, which is the magnitude of vector A. Now, what are the components of a vector? We have 3 points on xyz axis. Now, if I say you 1 1 1 is a point P, so how can you plot it? Yes. So OA will be 1, OB will be 1, OC will be 1. So the magnitude of each and every vector here will be 1. Unit vectors are denoted by I cap, j cap, k cap. So unit vectors along x-axis will be I cap. Unit vector along y-axis will be j cap. Unit vector along z-axis will be k cap. If a point P were given x, y, z, then the vector r from the origin to P will be xi cap plus yj cap plus zk cap. This form is known as component form. So xi cap, yj cap, zk cap is vector form. And clearly x, y, z will be numbers, so they are scalar component. And the length of r will be root under x square plus y square plus z square. If vector A is ai cap plus a2j cap plus a3k cap, then a1, a2, a3 are direction ratios of A. And what are LMN from the previous video? Yes, they are direction cosines. So if we write Li cap plus Mj cap plus Nk cap, we can also write it as cos alpha I cap plus cos beta j cap plus cos gamma k cap, where alpha, beta, gamma are the angles that the vector makes with x, y and z axis respectively. So starting with the question, find values of x, y, z so that the below vectors are equal. So a vector to be equal, the magnitude should also be same. So compare the two vectors, x equals 2, y equals 2, z equals 1. Now you need to calculate the magnitude of vector A and vector B. How can you do that? Following the formula root under x square plus y square. And if here we had z, then also plus z square. Next, find unit vector in the direction of vector A. So A cap equals vector A by mod A. So you have the unit vectors ready. Now you have to find the vector in the direction of A, and that has magnitude of 7 unit. So first you have to calculate the unit vector for A. And now you have been given the magnitude in the direction of vector A. So the vector becomes 7A cap. You have to multiply that scalar quantity with that unit vector. Next, you have to find unit vector in the direction of sum of vector A and vector B. So the first thing that you do is take out the sum of vector A and vector B. Let's name them as C. Now find out the unit vector C. Easy, right? Next question, calculate direction ratios and direction cosines for vector A, which is I cap plus j cap minus 2k cap. Direction ratio is nothing but the scalar component of the vector. So as we can see, A becomes 1, B becomes 1 and C is minus 2. Because before I cap what do you have? 1. Before j cap 1 and before k cap you have minus 2. Now find out the direction cosines. Direction cosines are the unit vector. How? Because you are calculating cos for that. Now cos is what? Base by hypotenuse. So L is 1 by root 6, M is 1 by root 6 and C is minus 2 by root 6. Next question, find the vector joining P and Q from P to Q. Since the vector is joining from P to Q, so you have to minus the P component from Q. Now let's begin with section formula. We have vector OQ, PQ and OP, where OP plus PQ is equal to OQ. You agree to this? Okay. Now a line OR intersects vector PQ and divides vector PQ in the ratio m:n. So vector OR plus RQ is equal to OQ. Now RQ is equal to OQ minus OR, which is equal to vector B minus R. So OP plus PR is equal to OR. So PR is equal to OR minus OP, which is equal to R minus A. Now we have the ratio given, PR by RQ is equal to M by N. So if you cross multiply, NPR is equal to MRQ. Now fill in the values for PR and RQ that you just calculated. So this gives you the value of R, which is MB plus NA by N plus M. Now if R was intersecting the line PQ at the midpoint, so it would have divided the line in the ratio 1:1. So N plus M would have been 2. So R turns out to be B plus A by 2. Let's take up a question. Suppose OP is equal to 3A minus 2B, OQ is equal to A plus B, and R divides PQ in the ratio 2:1 internally, which means the same as we saw in the diagram. We'll use the same formula. R is equal to MB plus NA by M plus N. So our R becomes 5A by 3. Now if R divides PQ in the ratio 2:1 but externally, so what will happen? The formula will change. You will have R is equal to MB minus NA by M minus N. Let's calculate and then I'll show you how this comes. So it will be 4B minus A. Now let's see how we can derive this, so that in case if you forget it in your examination, you can derive it by yourself. So following the diagram, we can see OP plus PQ is equal to OQ. So PQ is B minus A. Now OQ plus QR is equal to OR. So B plus QR is equal to OR. Now we have the ratio given, PR by QR is equal to M by N. So NPR is equal to MQR. Now PR is equal to PQ plus QR. So write the value of PQ, which is B minus A, and QR is OR minus B. So that comes out to be PR is equal to OR minus A. Now we have R is equal to MB minus NA by M minus N. Taking the next question, you have to show that ABC are the vertices of a right angled triangle. So first calculate the sides AB, BC, CA. So we have a hypothesis for this triangle. This can be wrong also. So let's see. We'll calculate the sides first, thinking that this is a final triangle. So as discussed previously also, if you have to calculate AB, you have to do B minus A. So if B has I cap, so you'll do I cap minus 2 I cap. Similarly, calculate BC and CA. Now take out the magnitude of each side. So clearly we can see that AB square is equal to BC square plus CA square, and this came from Pythagoras theorem. So our hypothetical triangle that we drew was wrong, and instead we need to change the triangle. I hope this was clear. If you like the video, please like, share and subscribe. Thank you.